What if a rocket intercepted a messenger from another star? Recently, the internet exploded with claims that a Falcon 9 rocket spotted something moving on the surface of 3IATLAS, an interstellar comet older than our own sun. But what's the real story behind this cosmic visitor and the rumors of its interception? The truth is more fascinating than the fiction, revealing the incredible challenges and profound possibilities of chasing these messengers from distant star systems. Let's explore this together. What makes 3IATLAS special? So what's the big deal with this specific comet? Imagine a visitor from a completely different neighborhood, one that holds clues to how other solar systems are built. 3IATLAS isn't just another space rock. It's a pristine sample of an entirely different stellar environment. It was discovered on July 1, 2025, by the ATLAS survey in Chile, a project co-led by astronomer Larry Deneau. That system is designed to spot near-Earth objects, so finding an interstellar guest is a testament to its incredible reach. Astronomers quickly confirmed its hyperbolic trajectory, the telltale sign of an interstellar origin. This object is racing through our solar system at a staggering 58 to 61 kilometers per second. To put that in perspective, you could travel from the Earth to the Moon in a little over 6 hours at that speed. Scientists estimate it could be up to 7 billion years old, predating our Sun. This means it carries a chemical record from an earlier epoch of the Milky Way galaxy. What truly makes it a scientific treasure is its composition. Observations from the Hubble and James Webb Space Telescopes show it's a true comet, complete with a dusty coma and tail carrying water ice, organic molecules, and silicate dust from its home star. The Falcon 9 connection debunked. Here's where the story gets twisted. Did a SpaceX rocket really intercept this interstellar traveler? The claim went viral, fueled by a public fascination with SpaceX's capabilities. But the reality is far more routine. Let's look at the facts. On August 18, 2025, a Falcon 9 rocket did launch from Vandenberg Space Force Base in California. However, its mission, overseen by figures like SpaceX's CEO Elon Musk, was to deploy 24 Starlink satellites into a low-Earth polar orbit. This was a milestone for sure, but entirely unrelated to the comet. There has been no spacecraft from SpaceX or any other agency that has intercepted or interacted with 3IATLAS. These kinds of rumors spread easily because they blend a known, dynamic entity like SpaceX with a mysterious celestial event. It's a compelling narrative, but it's pure fiction. The scale of an Earth orbit satellite deployment versus a deep space, high-speed intercept mission is colossal. Furthermore, space agencies are incredibly public about their scientific missions. An operation of this magnitude would be nearly impossible to hide from the global network of professional and amateur astronomers who constantly monitor the skies. The truth is, all Falcon 9 launches in that period were for planned payloads into Earth's orbit. The physics of interception. So, why couldn't we just send a Falcon 9 to check it out? The math is sobering. As physicist Andreas Hein of the Initiative for Interstellar Studies has detailed in mission concepts like Project Lyra, chasing an object moving at over 200,000 kilometers per hour is a monumental challenge. By the time 3IATLAS was identified, it was already hurtling outwards at immense speed. To even attempt a direct flyby, a spacecraft would need an epic velocity change. A Falcon 9 is a workhorse for lifting heavy loads, but it's not designed for the extreme velocity needed in deep space. You'd need a specialized and powerful kick stage that fires after the main rocket has done its job, pushing a small probe to incredible speeds. Even then, the launch window is punishingly narrow. Miss it by a few weeks, and the target is simply too far away and moving too fast to ever catch. Even our fastest spacecraft only achieve their speeds by falling towards the sun. To catch 3IATLAS, we would need a mission planned years in advance, likely involving a massive rocket and complex gravity assists, a luxury we simply don't have with these surprise visitors. Alien chemistry possibilities. This is where the science gets really exciting. What if this comet is carrying chemicals we've never seen before? Astrobiologists like Sarah Seeger at MIT spend their careers considering such possibilities. At an estimated 7 billion years old, 3IATLAS formed in a stellar environment that was likely very different from our own. The water, ice, and organic molecules detected might have structures fundamentally alien to our solar system's chemistry. This opens the door to a profound question related to panspermia, the idea that the chemical seeds of life are spread throughout space by objects like comets. Even more fascinating is the idea of chirality. On Earth, life uses what we call left-handed amino acids. There's no known chemical reason for this preference. Finding the opposite right-handed amino acids on 3IATLAS would be a monumental discovery. It would be powerful evidence for an independent origin of life's building blocks elsewhere in the galaxy. It would be like finding a recipe card written in a language that doesn't exist on our planet, profoundly impacting our search for life beyond Earth, and hinting that the universe is far more creative with its chemistry than we ever imagined. 3 missed opportunities. We're facing a pattern that is becoming painfully clear. In less than a decade, 3 confirmed interstellar visitors have sailed right past us. First, in 2017, came one Oumuamua. This bizarre object baffled astronomers. It showed no visible coma, yet it was accelerating away from the sun, a mystery that led Harvard astronomer Avi Loeb to famously propose it could be an artifact of extraterrestrial technology. By the time we spotted it, it was already leaving. Then, in 2019, 2I Borisov appeared. This one was clearly a comet, giving us our first real look at the chemistry of another solar system. Studies showed it had an unusually high concentration of carbon monoxide, a tantalizing clue that it formed in a very different, very cold environment, but without a sample, it remains a distant observation. Now we have 3IATLAS in 2025, our third confirmed cosmic messenger. It represents another missed chance for a close-up look. 3 unique opportunities, each with its own fascinating mysteries, and 3 misses. It raises the urgent question of how many more cosmic messengers we will simply let fly by while we remain stuck on the sidelines. Future intercept technology. So, are we doomed to just watch from the sidelines forever? Not necessarily. Imagine a spacecraft parked in space, just waiting. That's the core idea behind the European Space Agency's Comet Interceptor mission. Led by principal investigator Geraint Jones. Planned for launch in 2029, this innovative spacecraft won't have a predetermined target. Instead, it will travel to the Sun-Earth L2 Lagrange point, a gravitationally stable spot about 1.5 million kilometers from Earth, and wait, it will lie dormant until astronomers spot a new interstellar object with enough lead time. Once a target is selected, Comet Interceptor will begin the chase. It's 3 spacecraft in one. It will release 2 smaller probes to fly through the comet's coma from different angles, creating a 3D profile of its nucleus and surrounding environment. This isn't the only idea on the table. Some scientists at NASA have proposed concepts for rapid response missions. The goal is to move from passive observation to active pursuit, finally giving us the ability to reach out and touch one of these cosmic travelers. Scientific implications. What if we did manage to grab a piece of another star system? The implications would be, well, just transformative. As cosmochemist Connell Alexander has shown by studying meteorites, analyzing pristine material can totally revolutionize our understanding of solar system formation. Now just imagine doing that for another star. The primary goal here would be to analyze a pristine sample of matter from beyond our solar system. A key technique would be analyzing its isotopic ratios. Isotopes are variants of elements with different numbers of neutrons, and their ratios act like a fingerprint of the stellar nursery where the object formed. This could tell us if it originated in a region rich with the remnants of supernovas, for example. Furthermore, studying its trajectory with extreme precision could reveal subtle secrets. Tiny, unexplained deviations from its path could hint at unknown gravitational effects. And perhaps most compellingly, if we find complex organic molecules, it would really fuel the panspermia hypothesis, suggesting that the building blocks of life are constantly traveling between star systems. We might be looking right at revolutionary chemistry without even recognizing it. Trajectory analysis and mysteries. Let's dig into the path of this cosmic wanderer. The hyperbolic trajectory of 3IATLAS is the smoking gun that proves it's not from around here. Its path is an open curve, meaning it will swing around the sun once and then exit back into interstellar space, never to return. Its high hyperbolic excess velocity, the speed it retains after escaping the sun's gravity, is a key indicator. For 3IATLAS, this speed is around 58 kilometers per second. The object makes its closest approach to the sun on October 30th, 2025, at a distance of about 1.4 astronomical units. One of the biggest mysteries, a puzzle that astronomers like Bill Gray have spent years trying to solve for various objects, is its origin. Astronomers use powerful software to run the comet's trajectory backward in time, checking against star catalogs to see if its path aligns with any known star systems it might have passed millions of years ago. So far, no definitive origin star has been found for any interstellar object. They appear to be true wanderers, ejected from their home systems long ago, and drifting through the void for potentially billions of years. The official facts. So, let's separate fact from fiction and lay out what scientists have officially confirmed. 3IATLAS was first detected on July 1, 2025, by the Atlas survey in Chile. The 3I in its name literally means it's the third confirmed interstellar object. Within a day, its hyperbolic trajectory was confirmed by observatories around the world. As leading interstellar object expert Karen Meach has noted, the global coordination to observe these targets is incredible. It is traveling at a velocity of roughly 58 to 61 kilometers per second relative to the Sun. Hubble Space Telescope images from July 2025 revealed a dusty coma surrounding the nucleus. Spectroscopic analysis by both Hubble and the James Webb Space Telescope confirmed the presence of water ice, organic molecules, carbon dioxide, and silicate dust. NASA has officially stated that the object poses no danger to Earth, always remaining more than 150 million miles away. And to be perfectly clear, despite the viral rumors, no spacecraft, including any Falcon 9, has intercepted or is planned to intercept 3IATLAS. All SpaceX launches around that time were for routine satellite deployments. The bigger picture. In the end, the frenzy over a Falcon 9 intercepting 3IATLAS, while factually wrong, highlights a much deeper truth. Humanity is captivated by the idea of reaching out to these cosmic messengers. We've now seen 3 of these objects in just a few years, suggesting they may be common visitors. With projects like the Vera C. Rubin Observatory coming online, our ability to detect them will only increase. This isn't just a scientific question anymore, it's a strategic one. This connects directly to the Fermi paradox, a question famously championed by SETI astronomer Jill Tarter. If the universe is vast and the building blocks for life are being delivered across the galaxy like cosmic seeds, then where is everybody? Do we invest in developing a permanent, ready-to-launch intercept mission? The technology exists, but it requires political will and financial commitment. The decisions we make now will determine if, next time, we are ready to capture one of these cosmic opportunities, or if we will once again watch it disappear into the void, taking its secrets with it. The universe is constantly sending us messages, written in the language of chemistry and physics, carried on messengers like 3IATLAS. While we weren't ready this time, the future of interstellar interception is closer than you think. What secrets will the next visitor reveal, and will we be there to unlock them? If you want to be here for that next great discovery, make sure you're subscribed to Stellar Tech as we continue to explore the biggest mysteries on the edge of the galaxy. Don't forget to like, subscribe, and hit the bell icon. Thanks for watching.